everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. So far we've seen interactions with dummy variables where slopes differ across the groups. We've also seen interactions with a dummy and a continuous variable. Again, slopes differed across the groups. Now we're going to move to the most general case where both variables are continuous. So the model that we are going to work for the next few videos is going to look something like this. Y equals to beta 0 plus beta 1 x plus beta 2 z plus beta 3 x times z plus an error term. In this case, both x and z are continuous variables. The key idea is that the effect of x on y depends on z as well. But z is no longer just a 0 or a 1. It now can take many values. Okay? So z takes many values, which means that the slope changes continuously. So instead of having two lines, we now have a whole family of lines, which basically creates a plane. For each value of z, we get a different slope, so the relationship between x and y will smoothly change as z changes as well. So if you were to have a mental image of this, guys, drawing 3D is probably not the easiest, so I'm just gonna try and stick with a 2D here. So just imagine you've got X and Y here. Now, the thing is that you're going to have this line for Z, let's say equal to 1, and then you're going to have another one, which is Z equals to 2, and you can have another one, which is Z equal to 3, and you keep on adding a lot of those, like one even more like steeper than the other. And ultimately, like if you really were to imagine this as a 3D, so basically would have X, Y, and we'd have here basically Z. Think of it, I'm going to do it like this because imagine basically you have sort of like a box in a sense. Okay? So it would continue like this. And all of your observations would be here inside of the box. Imagine like this is like a smoke screen, and all of your Z lines basically would be on like a plane in here. Okay, so all of your Z lines. I know it's not the easiest and like the most obvious to visualize, but if it's easier, just look at the first graph in here. So basically you're looking at all of the lines with different intercepts, with different slopes, because the Z keeps changing all the time, okay? In the continuous case, the beta 3 is going to show how the slope of x changes as z changes. Okay, and the same kind of results that we have seen in the previous video will apply, where we've got that, well, if beta 3 is actually greater than 0, that means that the slope increases with z. And if beta 3 is actually smaller than 0, it means that the slope is actually decreasing, okay, with z. And again, if beta 3 is actually equal to 0, it means that there is actually no change. The interaction does nothing, so it doesn't depend on the z. If we stick to the variables that we have been using in the previous example, where we've got y income and x is our education in years. Let's assume the Z is now experience, how many years you've worked. The question would be, does education matter more when someone has more experience? And like theoretically, it would, like, if the beta 3 is 0, that means that education has a larger effect when you also have a higher level of experience. Okay? Now, if we compare all of the cases that we have seen so far, so we came from the dummy-only case where there was just one slope, you just had different intercepts. We moved into the dummy with continuous variable, where we saw that we had two slopes, to finally in the continuous times continuous case, where we actually have infinitely many slopes. Okay, so it was a gradual evolution, so to speak. And this is just a smooth version of what you have seen so far. So in continuous times continuous interaction, the effect of X changes smoothly with Z. And in the next video, we'll derive this formulae and compute the marginal effects, and then we'll also see a worked example. So stay tuned, and I'll see you in the next video.